Modern motor graders are marvels of engineering. '21st century design taking on traditional tasks. It's a classic understatement to say that motor graders are multi-purpose machines. They're used for grading, shaping, bank sloping, ditching, mixing, spreading, side casting, leveling, crowning, road building, parking lots, and building site construction. Plus, maintenance of all the above. In this program, we'll share operating tips that can help you do your job better, safer, and with more personal satisfaction, knowing that you're making the most out of these incredibly versatile machines. The productivity of all construction equipment, but especially motor graders, is dependent on the skill and creativity of the operator. Often, this job requires more in the way of touch than torque. You must have the ability to exert a very light touch on the controls, sometimes just tapping the levers, making slight adjustments, and using your concentration, hand-eye coordination, and finesse to make a smooth grade. Since you may already have experience under your belt, we'll skip a lot of the basic instructional material and assume you know how to operate and position the blade, tires, and circle. No matter what job you're preparing to do, every day must start with a walk-around inspection. It's best to catch a potential problem now, since you may be working miles from the nearest repair shop. Check the conditions of your tires and see that they're properly inflated for the job you're doing. Look for any fluid leaks or loose hardware. Be sure the blade and cutting edge are secure and in good condition. Check that the oil and coolant levels are okay. Be sure you read and understand the operator's manual. It lists the items that need to be checked in your walk-around. One last thing, take a look at the fuel gauge. More than one red-faced operator has had to stick his thumb out to get a ride back to the shop because he ran out of fuel. A couple of things about working safely. Follow all work zone rules in the area you're working, including the use of flashing lights or beacons. Be sure the one-call service has been contacted and the existing utilities in the area have been marked. Tragedy can strike if grades have changed or utilities were not installed properly. Remember that the machine is built for one person, the operator. Never allow riders. Keep the blade under the machine and the toe of the blade on the side away from traffic. That way, if somebody does run into you, they'll get a glancing blow, not a direct hit. Take extra care when working on slopes. Drive slowly and watch out for holes or ditches. When you're concentrating on your work, it's easy to forget that often laborers are checking string lines or grades in very close proximity to your machine. The pro often looks like their head is on a swivel, concentrating on the blade, but also making sure people are out of harm's way. If you lose sight of someone who you know should be in the area, stop the machine until you find them. Just so we're all speaking the same language, let's review some of the machine functions and positions. The toe is the leading end of the blade. The heel is the discharge end of the blade. The toe rides over the already finished surface, while the heel carries the grade. Blade side shift is the horizontal movement of the mold board. It's used for placement of the windrow and to gain reach around mailboxes and light poles. Circle side shift, as its name implies, shifts the circle either right or left. It's used to gain reach outside of the tandems and to counteract side draft. This is helpful when working on slopes, either pulling material down or pushing material up. Circle side shift also improves visibility to the cut by moving the circle out of your line of sight. Circle rotation is pretty obvious, but the point to remember is that the faster the material slides down the blade, the less side draft, which is the sideways force that the blade load places on the front end of the motor grader. Wheel lean can be used to offset side draft by leaning the top of the wheels in the same direction as the windrowed or discharged material. This will help stop the front end of the machine from sliding and will hold the wheels in a straight pass. The float position means the blade rests on its own weight with no hydraulic pressure. Float can be used to help you find grade on an irregular surface or to simply lower the blade to the ground. For normal blading, the pitch should be rolled forward just enough so that the material falls forward, creating a good mixing or rolling action. Pitch it back for less roll. For carrying material, the blade should be pitched nearly all the way back so that the mold board acts like a dozer blade. Having the blade pitched back also puts more drawdown on the blade, which increases traction. If the pitch is too far back, the material will boil over the blade and up into the circle. For cutting hard material and for visibility, roll the blade forward slightly to use the sharpest point of the cutting edge. This keeps the material from rolling, which is helpful when you don't want to segregate pre-mixed materials. Pitching the blade all the way forward decreases the blade's cutting ability. It increases the dragging action. The blade will tend to ride over material rather than cutting and pushing. It has less chance of catching on solid obstructions. Blade pitch is an excellent tool when feathering out material because it provides consistent height adjustment across the blade. For example, when an operator wants to raise the blade evenly when coming to an intersection, they simply roll the blade pitch back to raise the cutting edge, which feathers out the material across the width of the blade. On the old straight frame graders, all you had was wheel lean to counteract side draft, which is the sideways force that the blade load places on the front end of the motor grader. Modern graders offer articulation, which allows you to offset the two halves of the machine. Whenever possible, articulate the rear of the machine away from the discharge side and toward the toe of the blade. This will place the rear tandems directly behind the load. This position allows you to counteract the forces of side draft and handle heavier loads. Articulation also has other benefits. It allows you to have a smaller turning radius. Duck walking is a common term for when a machine wobbles side to side. By articulating, you widen the wheelbase, which helps reduce duck walking. The added width also helps with stability when the machine is on a slope. You can achieve more moldboard angle by articulating the rear of the machine away from the heel of the blade. Remember this rule of thumb. For most motor grader operations, you want to lean the front tires toward the discharge side and articulate the rear of the machine away from the heel or discharge side. Let's talk for a minute about cutting edge wear. The angle of wear on the cutting edge is determined by the blade pitch you use. If the pitch is changed, the angle of wear changes. You'll wear the cutting edge a lot faster if you use the point. Some inexperienced operators will get in the habit of pitching the blade forward so that they have better visibility to the cutting edge. The problem with this is that they grind off the point of the cutting edge. You'll extend cutting edge life by pitching the blade back so the flat side runs along the ground, and only pitching the blade forward in those instances when you need the cutting action that the point provides. Now that we've covered the machine functions, there's one more area we should address: the road cross-section. Whether you're building roads or maintaining them, understanding how a road is designed to function can help you do better work. The most important factor in road construction and road maintenance is drainage. Roads would last a long time if there were no frost or rain. But that's not the reality, so every road design has to allow water to quickly flow off the surface and away from the road base. Drainage should never be an afterthought. The main elements of the roadway are the crown, shoulder, foreslope, ditch, and backslope. The basic shape of the cross-section of any road must be correct, or it will not perform well, even under very low traffic. The crown of most roads will be determined by your engineering specs, but generally, will be between a 2 and 5% slope from the center of the road to each shoulder. Enough center elevation is needed so water flows off the road, over the shoulder, down the foreslope, and into the ditch. It's important that the ditches are free to drain. If water is allowed to stand alongside the road, it will seep back into the road shoulder and base, potentially loosening and undermining the foundation of the road. Expansion and contraction caused by frost can dramatically reduce the life of a road base. This is a 4-part training program. Part 1 is an introduction that includes tips on maintenance, safety, machine functions, and understanding the cross-section of a road. Part 2 discusses using the machine in construction applications, such as constructing roads, working on slopes, parking lots, and building sites. Part 3 deals with maintenance applications, like blading gravel roads, cleaning ditches, and snow plowing. Part 4 is a collection of operating tips that will help you in your day-to-day work. You may watch all 4 parts, or you may advance directly to your area of interest. As a professional, you understand that every job is different. Each job has its own set of variables, including moisture, slopes, specifications, and how the soil reacts to the blade of the motor grader. One job might take 5 or 6 passes, while another may take 10 or 15. We can't begin to cover all of the variables, but in this program we'll discuss techniques and tips that you can combine with your own experience to get your projects done better, faster, and safer. One of the skills that takes time to develop, but clearly separates the pros from the rookies, is the ability to visualize the finished job. Before you start the job, ask yourself some questions. What is the final product going to look like? Which high spots need to get cut, and which low spots need to get filled? In what direction is the water going to flow onto the job, and how will it drain off? The pros also gave us 2 pieces of advice. Don't move the material more often than you need to. And know what you want your blade to do before you even lower it to the ground. Let's put all of that advice to work as we take a look at some common grader tasks. In this first example, we'll build a roadway. First, we'll cut the ditches and backslopes, and then we'll construct and crown the road. The general principle is that you want to build a road up, not cut it down. As one pro told us, if the road's sides are higher than the surface, you don't have a road, you have a canal. For clarity, we'll do this demonstration on flat level ground. First, we'll make a scarifying or ripping pass to loosen the material. This pass gives an idea of what kind of ground conditions to expect and loosens up rocky areas. It also helps define the ditch line. A scarifying pass may not be necessary in all applications. One of the most productive ways to build a road is to work one side, then turn around and work the other side on the return pass. This helps make the job more efficient. The second pass will be a marking pass that establishes the ditch line. The grader is set to cut to the operator's right. The circle is side-shifted all the way to the left, and the blade is rotated to about a foot behind the right front tire. The blade is pitched forward a couple of inches to get a good rolling action, and the front tires are leaned to the left to offset the side draft. The cut material is windrowed between the tandems with the right rear wheels against the back slope. This pass should be deep enough to create a cut that the front wheels will ride in on the next pass. Drive straight, because the rest of your passes will follow in this cut. Remember earlier we said to side shift the circle all the way to the left? The reason is that you want the power of the machine to be directly behind the load or the cutting action whenever possible. Here, the toe of the blade is where the ground penetration occurs, so we want the power source, our drivetrain, to be right behind that. The next pass deepens the ditch. The grader is in the same setup position, except now the windrow is placed outside the left tandem. The heel is set to match the ditch slope angle you wish to achieve. Both the right front and right rear tires are against the back slope to hold the grader in a straight line. It will take several passes to get the ditch to the desired depth. Now the windrow along the ditch needs to be moved to the center of the road. This material will be used to build the crown. The rear of the machine is articulated away from the discharge side, and the wheels are leaned toward the discharge side to counteract side draft. The tandems are on the shoulder to compact the material. The blade is rotated to limit spillage off the toe. This pass only moves the windrow 4 to 5 feet to get the material off the shoulder. The weight of the grader helps compact the shoulder. 2 more passes move the material to the crown of the road. Okay, let's review what we've done so far. We started with a ripper, then made a marking pass, which established the ditch line, and created a groove for the tires to ride in for succeeding passes. Next, we deepened the ditch with a few more passes. Finally, we moved the windrow up to the crown of the road. The back slope is the next concern. If you have plenty of right-of-way, you can cut the back slope with the grader set in the traditional position. The machine is positioned with the tandems on the slope and the front tire in the ditch bottom. The cut material is delivered into the ditch. Later passes will move this material up onto the roadbed. Sometimes the right-of-way along the back slope is limited, and you'll have to use a different machine setup. To cut the back slope in this demonstration, the grader is placed in the bank position by side-shifting the blade to the right and moving the saddle all the way to the right. This allows the best reach to the right. The machine is in the ditch, with the right front wheel placed against the back slope. The blade is pitched forward to gain more reach and for better visibility to the cutting edge. Raise the toe of the mold board to give you the slope you want, and position the heel near the inner edge of the rear tire. Material from the back slope will be deposited inside the rear tires. After cutting the back slope, it's time to clean up the ditch. The goal of the work now is to windrow the material in the ditch that you've cut off the back slope onto the crown of the road. For these passes, the saddle pin is returned to the center hole position, and the front wheels are leaned slightly to the discharge side. The front of the machine is articulated toward the center of the road, with the tandems straddling the ditch. The circle is side-shifted to the right. Set the mold board to the depth of the ditch and set the heel to deliver the material up onto the shoulder of the road. Be careful not to cut the top of the slope with the heel of the mold board. The blade is pitched back, but not all the way back, so a good rolling action is maintained. The cleaning passes are repeated, moving the windrow to the center of the road. Before we begin working on the crown, let's go back for a minute to the ditch cleaning operation. Here is the machine configuration we just showed you. Now, let's go to the opposite side of the road for another setup that you might consider if the material is especially hard to work. This configuration has the left front tire riding in the ditch bottom and the right front tire up on the road shoulder. The machine is articulated so the left tandems are riding up on the back slope, and the right tandems are right down in the ditch, following behind the front tire. The mold board is set at a sharp angle and is cutting right behind the front tire. The saddle pin is set to gain maximum reach to the right. This is a good setup to use in tough conditions because the front tire riding in the ditch helps you drive straight and prevents the front of the machine from getting pushed around by hard material. Next, we'll crown the road. Start by pitching the blade forward. Work and shape the crown in both directions, with your tires riding right on or very close to the crown. Be careful not to cut the centerline crown, which will cause the center of the road to become flat, essentially destroying drainage. Several passes may be needed to compact and spread the material to crown the roadbed. By articulating slightly, the front wheels will be offset from the rear wheels, so more material can be compacted per pass. The final grading pass should feather out, creating almost no windrow. Slope work is interesting and challenging. The key is to put the blade in the correct position and control your speed. Front-wheel drive and six-wheel drive machines are excellent for slope work and will help make the job easier. It's a good idea to rough in a slope by starting at the bottom. This allows you to detect any soft spots and compact and fill in any voids. To move material up a slope, the machine is articulated so the tandems are on level ground and the front tires are up on the slope. The saddle is in the far right position and the circle is shifted right. There is slight spillage off the toe of the blade with the right rear tandems compacting the area next to the small windrow. On the next pass, the grader operator runs his left tandems along this windrow, which helps hold the machine on the slope. On machines without front-wheel drive, using wheel lean will help keep the front end up on the slope. Articulation allows you to gain more moldboard angle, which helps move the material up the slope. Remember, gravity is trying to pull the material down the slope, and you're trying to push it up. Pitching the blade forward will give the material some roll. This helps keep it moving along the blade. For finish work, you can start at the top and work the material down the slope. Here, the grader will reach to the right, so the saddle is moved to the right. The circle is side-shifted almost all the way to the right. With the differential locked, the operator begins the pass. Articulating provides more stability by giving you a wider stance on the slope. Put the heavy rear of the machine on the downhill side. The wheels are leaned up the slope slightly. Pass the material downhill between the tandems. This windrow will help hold the machine on the slope. Keep making passes until you're satisfied with the slope. If the machine begins to slide, adjust your blade rotation to reduce the amount of material you're carrying. If that still doesn't stop the slide, carefully back down the hill. Parking lots come in all shapes and sizes and can be a real challenge to the motor grader operator. The key is to visualize the job and understand drainage. First, ask yourself the question, what needs to happen on this job? Take a look at the job site survey and plans. Visualize the finished project. Where are the high spots that need to get cut, and where are the low spots that get filled? Consider the two factors in what the pros call water management: run-on and run-off. Run-on means finding the path that water will take to run onto your project. If you're making a parking lot partially into the side of a hill, you know where your run-on is going to come from. Run-off is the path the water will take to drain off of your project. Are there drains involved in the project, or will you be required to slope everything downhill? Once you visualize the job, start to develop a plan as to how to move the dirt in a way that the highs get cut and the lows get filled. Let's look at two examples. Here we want to create a parking lot that drains to one corner. The first thing is to identify the low spot where the surface water will drain. The drainage pattern will look like this. In a perfect world, The amount you have to cut would equal the amount you have to fill, and you wouldn't end up with any extra material. But this isn't a perfect world, so your first consideration is going to be, where can I get rid of my extra dirt? We'll identify this area as the place where we want to push the extra dirt. It's usually a good idea to plan your project so that you start at a known elevation and work away from it, keeping the dirt moving in the direction of the spoil pile. Let's start by cutting the curb grades along the perimeter of the parking lot. This will establish a known elevation and give us some operating room to cut the rest of the parking lot. Since we want to be moving dirt toward the spoil pile, our first pass will move along this edge. Our second cut will be along the far left edge and will move the material to the corner. And our third pass will cut along here, again moving the cut material in the direction of the pile. Now we've established our curbs and can work from those known elevations to begin to shape the lot. For the next passes, we'll keep the tandems on the finished grade to help stabilize the machine. The toe of the blade rides on the finished grade, and the heel discharges the cut material onto the unfinished ground. With the tandems and the toe riding on the finished grade for each pass, you can carry the grade all the way down to the opposite curb line. Try to keep the material you cut with the blade controlled and captured as you work. Now you've got everything cut close to grade, and your final passes will create the drainage pattern. You have a choice to make as to which side of the drain line to do first, Area 1 or Area 2. It makes more sense to do Area 1 first, the side furthest from the spoil pile. You want to minimize having to cross over finished work. If you finished Area 2 first, you would disturb the finished grade when you move the spoil from Area 1 across it. Start with the deepest cut and move the dirt up and away from it. Again, the toe cuts to grade and the heel discharges the material out away from the cut. Cleanup passes move the material to the spoil pile. Now cut the other side, using the toe to cut to finished grade, and then carrying that grade on the rest of your finishing passes. Notice that our work pattern in this example kept the dirt moving in the general direction of the spoil pile and didn't cause the machine to have to cross over windrows or over finished work. Let's look at another, more complex example. Remember, there may be several different ways to approach any given job, and they all may be successful. Here, we'll show one way to plan this job. We're going to finish grade a parking lot in front of this store. The lot is going to be paved and will drain into 2 inlets in the middle. We've identified this area as the place to push the extra material to be hauled away later. Since the store and sidewalk are already in, you can't start your push from here. You'll have to work back and forth along the edge in order to create a margin or border to create enough working room away from the sidewalk. Next, it's time to visualize the finished job. What you're trying to build resembles 2 X's, with a drain in the center of each X. For the moment, ignore the right half of the parking lot. The sidewalk and the drains are already in, so we have those established elevations to work from. Now we'll make the 2 curb cuts, here and here. These cuts move the material to the spoil pile. Now, if we visualize our drainage pattern, we can see that there are 4 cells that each drain to the center, A, B, C, and D. We'll grade 1 cell at a time, remembering that we want to create a smooth cross slope from one known elevation to another. Keep the material moving in the direction of the spoil pile, and limit how often we have to cross over our already finished work. We'll start with cell A, the farthest from the spoil pile. We'll make the drainage cut first. This creates the cross slope from the curb elevation to the drain elevation, It also provides a border or margin for you to get your machine squared, and it establishes the correct grade for the starting point of each of the next passes. Next, starting at a point furthest from the spoil pile, we'll make a series of passes that begin with the drain line elevation you established with the first cut. Each pass moves the material onto the next cell. Now we'll begin work on cell B. The first cut moves in the direction of the spoil pile and establishes the drain line elevation. The next series of passes move the material onto cell D. Now we've got cell A and B finished. We'll work on cell C next, since it's further away from the spoil pile than cell D. We don't want to cross over finished work. Cell C is worked a little differently than the other cells. The left side drain line was already established when you did cell A. So the next step is to establish the right side drain line elevation. Succeeding passes will grade between those two lines, moving the dirt on to cell D. Cell D is worked by cutting the final drain line elevation, again moving the material in the direction of the spoil pile. Succeeding passes move the material out of the cell. Next, you'll move that material over to the spoil pile. The procedure is repeated for the right side drain field. Obviously, your work will require more passes than we've shown here, and there are undoubtedly other ways to get the job done, but this illustration gives you some general ideas about how to approach a project like this. The subgrade should be at the final desired parking lot elevation minus the planned pavement thickness. Don't forget, the paver who comes behind you will prove your work, right or wrong. If you're working on a cul-de-sac, some of the considerations are the same as with parking lots. You should visualize the finished project, identify the high and low spots, and determine where you can put the extra dirt. If the curb and gutter are already in, you can start from the low spot, which is the gutter, and begin to shape toward the crown. When you get close to grade, put the machine into the articulated mode to improve your turning radius and help keep your tandems from riding up on your windrow, and work the grade in a continuous circle. Keep the mold board pitched slightly forward so you can match the end of the cutting edge to the face of the curb. This also improves the sight line to the toe of the mold board as you're trimming against the curb. Once the outer edge is finished, begin trimming the rest of the grade while working the material toward the entrance. Try to keep the drawbar of the machine parallel to the finished grade. This can help eliminate cross-slope errors when you circle the mold board. Finally, extra material is moved out of the cul-de-sac. You'll have to match the crown of the cul-de-sac with the crown of the street. Be sure not to cut the crown. Cul-de-sacs are one of the real challenges of grader operation. When you can master these, you can call yourself a pro. One of the skills that separates the pros from the amateurs is the ability to shape the crown at a curve in the road. Here's a look at a section of roadway. The straight section is crowned in the middle, but as you approach the curve, the crown gradually transitions from the middle to the edge of the roadway. This super elevation sheds the water to the inside of the curve. This is a good example of the need for visualizing the finished product. The curve should have a consistent cross slope from shoulder to shoulder. Be careful not to cut down the outside shoulder. That causes the super to become crowned. The cross slope should become steeper as the curve becomes tighter. Motor graders are often used to spread material when constructing roads, building sites, and parking lots. These projects usually require the fill material to be placed in lifts and compacted to ensure the foundation meets density requirements. A grader is a good choice because, in contrast to a dozer, they can be more precise when placing the lifts. They are better at mixing the material with the rolling action that the blade provides, and they're faster and less expensive to operate. Coordinate with the truck drivers so they dump their loads in the right areas, not too close together or too far apart. You'll be more efficient if you work alongside the piles rather than wasting horsepower trying to drive through them. Articulate so the tandems are behind the load for power and cut a section off the pile that you can easily move and spread evenly. Work the material in both directions so you don't spread it too far one way. Get enough material kicked out all the way to the grade stake. Once the piles are spread, work with the water truck to mix and process the new material. Your accuracy as a motor grader operator has a direct bearing on the profit or loss on a job. Base materials and paving materials are expensive. If an inaccurate subgrade causes a contractor to use more base or paving material than the job specs called for, the cost to complete the job is going to rise. Remember that even 2 100ths or 3 100ths of a foot of paving material costs a lot of money over the length of a grade. Automated blade control systems are a rapidly advancing technology that have become a very popular feature on motor graders. One of the contributing factors in achieving the high accuracy of these systems is that they reference signals from several satellites, usually at least 5. At certain times during the workday, there may be fewer available satellites for the system to reference. These blackout periods are usually short in duration, but it's important for job productivity that you have a backup plan for those times. You might suspend your fine grading work until you get your signal back, and temporarily move to another part of your job where you're doing less precise work, or even plan your lunch break for those times. Automated grading with GPS has enormous potential for increasing job site productivity, but operators still need to understand the basics of earth moving and grading. You must have confidence that the automated control system is performing correctly and is helping you build the job that you visualized when you started your day. And most importantly, you need to be able to recognize any errors and correct the job if the system isn't working as it should. As one of the pros told us, a GPS system can make a good operator better, but it cannot make a bad operator good. He also said, "I don't care how good it looks. Professionals get paid for how it drains when it rains." Whether you're using GPS or not, there is no argument to standing water. Nearly half of all the roads in the United States are unpaved. These roads provide a means of getting farm products in and out of fields, timber out of forests, and access to remote areas like campgrounds and lakes. Many rural residents are served by gravel roads as well. Combined, there are over 1.6 million miles of roads that need regular maintenance. For many citizens, the maintenance of public roads is one of the most visible uses of tax dollars, and your work as a motor grader operator influences public opinion about how well government is spending their taxpayer money. Increasingly, gravel road maintenance funds are being squeezed. Money that is available is directed to paved roads, and the motor grader operator, who has the primary responsibility for the condition of gravel roads in a municipality, is asked to do more with less. In this program, we'll cover these topics, which combined with your skills and creativity, will help you get the most out of your machine. The pros talk about understanding your gravel. That means knowing the makeup of the material you're working with. Good gravel is the proper blending of stone, sand, and fine-sized particles. Traffic tends to loosen a road surface, causing the coarse material to separate from the fine material. The stones roll off, and the fines settle down into the roadbed with no base to support them. Goodbye base. Hello ruts. Ideally, your gravel road profile should resemble that of an asphalt road, a firm, compacted base with a blending of coarse and fine gravel providing a smooth driving surface and shaped to provide drainage to the ditch. So how do you get this blending of material when the coarse material is over here and the fine material is in the middle? The answer lies with the grader operator and how they use their blade. They have to recover both types of material, mix them by rolling the materials along the mold board, and then distributing the mixture back across the road surface. In fact, the lack of a good mixing action will further separate the coarse and fine material. One operator we talked with said he can tell a rookie has bladed a road because the rock will be piled up along the edge of the road instead of being integrated into the base of the road, where it can do the most good. The crown of most roads should have a 2 to 5% slope from the center of the road to each shoulder. This allows water to flow off the road, over the shoulder, down the foreslope and into the ditch. Problems develop if the water can't drain off and collects on the road surface. It will soften the crust of a gravel road, and if it seeps into the subgrade, will lead to rutting. Even if the subgrade remains firm, traffic will quickly pound out smaller depressions that collect water and form potholes. Traffic will determine how often gravel roads need to be maintained. The day after a rain is an excellent time to grade roads. The moisture will help shape and compact the road material back into the crown. If this is your first season on these roads, take a drive with someone who has experience with them. Take note of obstacles and potential trouble spots. Be sure you know where the buried utilities are. Know your organization's policy about when to contact the one-call service and have the utilities marked. Remember, the flags and painted lines tell you the path of the utility. They do not tell you its depth. Tragedy can strike if erosion or road construction has lowered the ground surface, bringing it closer to buried utilities. Before you start work, take a minute to assess the situation. If the road surface has only some minor washboarding or low spots, your work will be less involved, probably amounting to cutting the road surface down a few inches and redistributing the material in compacting it. If the road is deeply potholed or rutted, or if it has completely lost its crown or shoulder, you have some extensive work to do. This involves pulling the ditches, meaning cleaning or reestablishing the ditch and slopes and pulling the excess material up onto the roadway and creating a new road base and surface. We'll look at both scenarios. A worn road looks like this. Fast-moving traffic scatters loose material that tends to build up along the shoulder line. This edge material has been displaced by tire action. Use this material. It is gold. It's ideal for mixing with coarse material for use in filling in road imperfections because it's already processed to size and contains no weeds or organic material that would decay and create a void. This material will be moved up to the crown and then mixed and bladed back into the roadway. Take a look at this road. It has several problems that are common to gravel roads. The fines and the coarse material have separated. Washboards and ruts have formed that hold water, and the displaced material has raised the shoulder, preventing water from running off the road and into the ditch. Without bringing any new material in and using only the motor grader, we'll rebuild the road surface by cutting down to the base, reclaiming and mixing the displaced material, and reestablishing the crown. For the edge passes, the motor grader is slightly articulated to improve visibility. The wheels are leaned slightly to counteract side draft. Circle side shift is in the middle, and the blade is pitched slightly forward. The blade is angled just enough not to lose any material off the toe, and deep enough to cut to the road base. You want the material to fall forward, creating a good mixing action that moves the recovered material from the shoulder across the roadway, leveling and smoothing it in the process. You should cut down all the way to a hard base. Do the same on the other side of the road. Now you've got two windrows near the crown of the road. Next, the operator will cut the center section of the road down to the base, continuing to roll and mix the material. On the next pass, he begins to shape the crown. The machine is slightly articulated, giving it a wider width, which helps with compaction. He's carrying enough material in front of and along the length of the blade to fill in any low spots in the road. He'll make a similar pass on the other side of the road. On the final pass that shapes the crown, the blade is nearly square to the frame, and the last bit of windrow is picked up and spread evenly across the front of the blade. Notice the material flows under the blade rather than spilling off either end. This eliminates windrows on your finished road. To know how much material he's carrying, the operator watches for daylight and the amount of material sliding under the blade. After reshaping the road, the traffic will compact it. However, rolling the surface after shaping will give better and longer-lasting results. Blading a road the day after a rain is a good idea, but if you're sinking down into the roadway, it's too wet. It should be wet, but not muddy. You want to get out there while there's still enough moisture to mix with the surface and compact it. If it's too dry, don't waste your time, unless you have the services of a water wagon. Washboards on a gravel road are as common as weeds in the ditch. When planning your repair work, be careful not to make the situation worse. If you have the right moisture content, you can level the surface by cutting across the corrugations. Adjust your blade angle so the cutting edge does not follow or mimic the corrugation pattern. Cut the surface to the bottom of the corrugations and then reshape the surface by spreading the windrows in an even layer across the road. When cutting washboards, changing the machine's articulation will help control machine bounce. This changes the rhythm of the bounce, helping to smooth the grade. Remember, washboards and potholes both must have the surrounding areas cut down to the base, mixed with the other roadway materials, and brought to a consistent compaction level. Simply filling in or scooping out individual potholes will not work for the long term. If you have roads and ditches that are in poor condition, you really have no option but to rebuild them. The goal here is to reclaim material that has washed or somehow been displaced into the ditch and move it back up onto the roadbed. Then the roadway materials and the reclaimed material are mixed, processed, and bladed to form a new crown, shoulder, and foreslope. This stretch of road is badly deteriorated and needs to be rebuilt. There is good gravel and fines that can be saved, so the first pass will temporarily move those materials over to the crown. This pass also cuts the road edge and shoulder down to a solid base. The next several passes work to re-establish the ditch line, with each pass cutting deeper. Notice the articulation and use of wheel lean as the operator cuts the very sticky material out of the bottom of the ditch. Now the front left tire rides in the ditch line to help hold the machine in a straight line, with the tandems up on the roadbed. Now the operator is working to create the foreslope. The blade is set to the desired angle of the foreslope. The rear of the machine is articulated toward the discharge side of the blade, with the wheels leaned in the same direction. The spoil is cast inside the tandems. This helps the operator maintain the correct blade angle, since he's not running his tires up on the windrow. Now the operator makes several passes in both directions that mix and blend the roadway materials, including the gravel and the native material. During the final passes, the road crown is reestablished. The blade is nearly square with the road surface, as the mixed material is feathered out and compacted by the rear tires. The same reclamation technique can be used to correct this condition, where a rut has formed on the road shoulder that intercepts water and holds it next to the road surface. Remember, you want the water to drain away from the road, not sit in a puddle next to it. You're money ahead anytime you can reclaim gravel and reuse it, rather than having to haul in new material. Be careful of taking too much material from the foreslope. This can narrow the shoulder and create a steep area that is a hazard for motor vehicles if they have to pull off the side of the road. If you need extra material to rebuild the crown, it's better to pull it from the ditch bottom or the back slope. Sometimes in road maintenance, you'll find a ditch that holds water instead of letting water drain away. Ditches can silt in from soil sloughing off a slope or water running into the ditch from a field. These high spots act like dams and restrict proper drainage. If you have water standing in the ditch, you must first remove the plug to get the water flowing again. Wait a few days to let it dry out before you clean the ditch. When you clean the ditch, you have the choice of either moving the material up the foreslope and working it back into the road surface, or, as we'll demonstrate here, removing it from the ditch and taking it up the back slope. The initial pass reestablishes the ditch bottom. The mold board is set at a sharp angle, and the machine is articulated, with the left rear tandems up along the shoulder of the road. The blade is pitched slightly forward for a good rolling action, and the right rear tandems ride in the bottom of the ditch. This compacts and firms up the trench bottom. The next pass finds the grader up on the shoulder, using the ditch bottom you just reestablished as a guide and shaping the foreslope so water coming off the paved surface can flow directly into the ditch. It may take more than one pass. The next few passes move the material from the bottom of the ditch up the back slope. Notice that the circle is side-shifted to the right, and the front left tire rides in the ditch line, and the back of the machine is articulated away from the heel of the blade to counteract side draft and to put the power of the machine directly behind the material being cut. In the ditch we just cleaned, you can see that the tires were used to compact the trench bottom. The windroad material will be left to dry out for a few weeks and then spread so it doesn't interfere with roadside mowing or the soybean harvest. A common challenge when cleaning ditches is trying to get the angle of the foreslope just right. In many cases, the ditch is deep and you can't get enough blade angle to shape the foreslope, and you end up cutting the top of the shoulder off. Here, the circle lift cylinder rod on the left side is almost fully retracted, preventing the operator from raising the circle any higher to achieve the desired angle. The solution is to move the saddle pin one hole away from the ditch. The pin should be moved the opposite way the blade is trying to reach. This gives you more cylinder rod movement to lower the right side of the circle and raise the left, giving you more reach into the ditch and more heel clearance. This will help you avoid cutting the top of the shoulder. Engineers say that a wide, flat-bottom ditch will handle more water volume than a sharp, deep cut. A V-ditch will silt in before a 2-foot wide, flat-bottom ditch will. Additionally, a gradual backslope will allow the water to flow away from the road, especially in a high water situation, versus a steep backslope that concentrates the water closer to the road base. If you have a V-ditch that's prone to silting in, consider changing it to a flat-bottom ditch. The right rear tandems are in the ditch bottom, putting the power right behind the cutting point of the blade. The front tires are up on the foreslope. The operator will make a series of slicing passes at about the same depth as the original V-ditch, with each cut gradually widening the trench bottom. Here you can see the cuts for passes 1, 2, and 3. A pass in the opposite direction moves the windrowed material out of our way and onto the roadway. Next, it's important to re-establish the tow line of the backslope. In the next pass, circle side shift is used to create enough blade angle to allow the entire blade to fit into the ditch bottom. This pass cuts the flat bottom. The toe of the blade rides in the tow line you just re-established. The material is discharged between the tandems. Final cleanup passes move the windrow out of the ditch. Notice the operator is using the front tire to pinch the edge of the windrow. This compacts it, which helps the material move up the blade and out of the ditch. You can clear a plugged culvert with the grader. Put the blade in the bank position and use the blade side shift to lower the blade to a point just in front of and below the culvert opening. Using circle rotation and blade side shift, you can simply drive forward to remove the plug. The shoulder is an important part of any road. It supports the edge of the traveled portion of the roadway and provides a safety area for drivers to regain control of vehicles if they're forced to leave the road surface. They also carry water away from the road surface to the foreslope and the ditch. The shoulder must be shaped properly. It should meet the edge of the roadway at the same elevation. If it's too high, it'll prevent water from running off the roadway. If it's too low, there will be a drop-off, creating a safety hazard and reducing road edge support. A good way to handle high shoulder situations is to cut off the high spots and load and haul the material away, but that's expensive. An alternative is to do what's called sweeping it under the carpet. That means we'll move the displaced gravel from the edge of the road and windrow it to the center. Then we'll make a small ditch that parallels the edge of the roadway. Next, we'll cut the high shoulder material and flip it into the ditch we just created and compact it. Finally, we'll blade the gravel back across the road surface and grade the shoulder so water can easily drain to the ditch. First, we'll move the displaced gravel to the center, and at the same time, we'll cut down to a hard base. To set the grader, lean the wheels and side shift the circle. Use blade side shift and pitch the blade slightly forward for a good rolling action. The machine is articulated to place the power behind the blade and for better visibility. Cutting and moving the gravel may take several passes. After the gravel is windrowed to the center of the road, cut the small ditch that parallels the roadway. It should look like this. Now, cut the high shoulder down to the correct grade while rolling the high shoulder material into the ditch. Cut a little wider on the next pass, again rolling the sod into the ditch. Working in the opposite direction, the spoil from the secondary ditch is placed over the sod. Use the grader's wheels to thoroughly compact the material. In this procedure, since you're trying to dispose of organic material, the importance of compaction can't be stressed enough. Once the shoulder is shaped, the gravel you windrowed earlier is mixed and rolled back onto the surface and shaped to re-establish the crown. Be sure to thoroughly compact the road surface. The high shoulder is gone, and water has a clear path to flow off the road. Motor graders are excellent machines for moving snow, whether it's routine plowing or opening roads after big storms. Before tackling any drift, make sure you know what's underneath all that snow. This is not the way to find out. When opening a road, whether equipped with a standard plow or a V-plow, it's important to know your machine's capabilities and work only as fast as conditions permit. You're not likely to get it all in one pass. And remember, speed is not the answer to getting the job done safely. Six-wheel drive is very handy to have in these situations. If you lose traction, you'll have to raise the blade to lighten the load to keep the tires from spinning. Use tire chains or call in a heavier machine. Let's talk for a minute about the wing. The wing gives your machine extra reach to get the snow further off the road. In high snow conditions, you can use the wing to bench the edges. Try to match the angle of the wing with the angle of the mold board so the snow moves off the road in a consistent angle of flow. For fine control of your machine, it's important to have the machine level. This may require you to put additional air pressure in the tandems on the side of the wing. Randy Fetting has been operating motor graders in the Rocky Mountains for over 30 years.
If it's yellow, it moves dirt, I'll operate it.
He uses a 3-day system to deal with the big snowstorms. Day 1, he opens the road using the front plow.
Up here, the degrees of the angle of the slope will vary from corner to corner every 200 yards. These are the Rocky Mountains. You got deep gullies on one side and straight up and down cliffs on the other. So depending on room, how steep the grade is, if I'm opening up a road right after a snowfall, I'll usually use the front plow. I'll pin the wing up.
Again, he knows his machine's capabilities and uses 6-wheel drive and blade angle to gain a foothold. For the next passes, he begins to use the mold board by lowering it to the ground, then raising it about 1 inch to give him some clearance.
Mold board float, bring back up, bump it up about 1 inch, 1/2 inch. Take care of the dingers that we got in the road. Dinger being a rock that's part of the road base, which nobody likes.
Day 2, he widens the road using the wing.
They'll use a wing. I'll use it. Operators use it on the second day, or pretty much second day, to widen, because you can keep your machine on the road and your wing can go out over the edge. Always keep your machine, the rear end of your machine, articulated on the road. That way, if something happens to the front end with this 6-wheel drive, it will back you out. If your engine and your weight is on the flat, and if you can keep down to dirt each snowstorm, then it's easier on the machine to cut pack.
Cutting pack means using the mold board to cut the packed snow down to the level of the gravel or pavement. Randy puts a high value on being familiar with the roads you're working at all times of the year.
It has always been my belief that to maintain a proper area, you put one man in your area. They have their own blade, their own route to run, and then that way he'll know what he's doing in the summer, where his culverts are, where his rough spots are, and come time to plow snow, the road's in good shape, then he knows driveways and his complainers on the route. During the summer, I blade a road to plow snow as fast as I can, as smooth as that road can be. Then winter hits, I'm blading that road with the mind that I do not want to lose all my material down over a bank and can't gather it back up come summer. Just little tricks that I've found while I'm plowing snow to make the next storm easier, the next day that much easier.
Day 3, Randy takes care of any remaining snowpack and does general cleanup. It's just in time, too, because another storm is blowing in. Keeping haul truck cycle times to a minimum can increase the productivity of any job. For all roads, but especially haul roads, you want consistent grades across the road surface. This decreases the truck's rolling resistance and can eliminate unnecessary downshifting by the haul units. In icy or muddy conditions, poor traction can become a hazard. The grader can be used to cast surface mud, snow, and ice to the side. It can also be used to remove large rocks from the road surface. Haul truck tire failure can be extremely dangerous and costly. If possible, have your truck drivers vary their tire tracks slightly so they compact the entire road surface, not just two ruts. Finally, here's a collection of operating tips that you can use in your day-to-day work. Lean the top of the tires in the same direction the windrow is being discharged. This permits better tire grip to counteract side draft. Articulate so the back of the machine is away from the heel of the blade. This improves visibility to the cut, helps keep your tandems level, and allows the machine to move more material by offsetting side draft. If it's not possible to articulate away from the heel, dump the windrow between the tandems. This can be used for pulling a wet ditch and keeping the drive wheels on the road surface. For a wider compaction swath, articulate the machine slightly, allowing the rear tandems to run offset from the front tires. You can help judge blade distance from the ground by watching the shadow of the blade. The toe of the blade requires more attention and adjustment than the heel, because the toe is positioned to make a smooth transition from the previous grading pass. Every time you look at the blade, you're judging how deeply the blade is cutting. When fine grading, it's important to keep the rear wheels of the machine on as flat and level a surface as possible. This will help you control your blade. Watch this demonstration. The grader is spreading this windrow. But when the operator gets his left rear tires on top of the windrow, it throws his blade tilt off, and he begins to gouge the surface at the toe. If he continues to operate this way, he'll have to constantly adjust his blade to try to correct for it. Remember, when fine grading, keep the rear wheels on flat and level ground. Here's a technique for turning around in a tight spot. Drive just beyond where you want to turn around. Back up and turn using articulation. The front of the machine will follow right behind the tandems. Using articulation in this way will allow you to turn sharper than if you used front steer alone. To prevent the machine from tipping when turning downhill, use your articulation to gradually move back to the straight frame position. Sometimes it can be difficult to keep the machine stable while carrying a light load of material. Machine bounce, or loping, can be minimized by reducing your speed, leaning the front tires in the direction that the material is being moved, changing blade angle, changing blade pitch, staggering the air pressure in your rear tandems. For example, the right front tire is set at 25 psi, the right rear 22 psi, the left front 22 psi, and the left rear 25 psi. To reduce duck walking, which is a side-to-side wobble, reduce your speed, articulate the machine, or adjust the blade angle. Even the most experienced operators are constantly finding ways to improve their efficiency. Using the correct speed is critical. Too slow, and you'll sacrifice productivity. Too fast, and you'll sacrifice accuracy. By slowing down, you'll have more time to adjust the controls to where you can keep a smooth, uniform grade. Grader efficiency is directly proportional to the number of passes made. For example, if 4 passes will complete a job, every additional pass increases the time and cost of the job. Operator skill and planning will help eliminate unnecessary passes. When spreading out windrows, you can pitch the blade slightly forward. This allows the operator to travel faster because the material pushing up on the blade helps stabilize the machine and prevent tire bounce. If you're spreading a windrow and loose material is working its way up to the toe and spilling over, steer the front tire so it runs up on the edge of the windrow. This little bit of compaction will help prevent spillage off the toe.